So sounds to be good. Here we go. Okay, so welcome to Troy today in the channel. First time interview, so I'm really blessed with the host today. Thank you, Troy, for accepting this invitation.
Yeah, thanks for having me.
We're going to talk about the Wave Sentinel that Troy designed and built. It's really impressive. So we might have like some demonstration soon, thanks to Troy. But before this, Troy, could you introduce yourself, please?
Yeah, so obviously my name's Troy, and I'm an engineer, a communications engineer, and just have a keen interest in radio in particular. Also a ham radio operator, so I've always enjoyed radio, and so this is kind of one of the little projects that I've kind of came up with due to the interest that a lot of people have in the sub-gigahertz and Wi-Fi world. Kind of wanted to bring something that would have open source support and maybe get a little community, meet some other people that are like-minded and enjoy that sort of thing. But my background is in RF. I've worked with Motorola, IBM, done a lot of infrastructure projects with RF. A lot of work with public safety with RF, and so this is just kind of something that's always interested me.
So did you came with this project because you bought Flipper Zero, or it was something that already was in your mind because you kind of tinker with like transceiver modules?
I definitely had done some previous messing around with the transceiver modules, mostly like the 818 for DMR, mostly for like ham radio use. But then I was on part of the with the flipper when you pre-purchase it, part of that. So I waited for a while. I got it, and that's really what stirred the interest in creating the Wave Sentinel, and mainly because a lot of people were having trouble getting the flipper, or they're in countries where they're restricted. Shipping was, a lot of trouble, for people to be able to get their hands on it. And so, and it seemed to me that the sub-gigahertz and wireless kind of capability seemed to be the mainstream interest when it came to flipper. So this was a way to bring some of that same technology to open source, so people could easily get the parts for it, put this together, and be able to replay the sub files that are on a flipper. I think that was a lot of things, even as simple as popping the Tesla, charge ports for a lot of people seem to be a real interest. So we even put a dedicated button just to do that. but yeah, ultimately that was really the flipper was Flipper Zero was the kind of the driving force at wanting to put this together to be able to bring some of that same features, to people without having to with the limitations of being able to get the flipper.
Yeah, and I've seen you already included like the .sub extension file, so there is an interoperability between like the Flipper Zero and the Wave Sentinel. You could use the same file and saving the sub-gigahertz transmission.
Yeah, correct. Right now, it is just the file would have to come from the flipper and then be played, or you could download it. Obviously, there's a lot of GitHub repos that actually have those sub files available. So right now, it's strictly playback, but would like to potentially have a mode where it could, when it does do captures, that it would be able to do that in that same format, so they would be compatible with each other. I'm still trying to work out some of the code to be able to do those things, but ideally that would be the main goal, is to be able to do that. And there's also some other modulation kind of schemes in there, and protocols that are available, that where they've kind of got 4 of them that are primarily set up for the flipper, but there are some other things that the CC1101 is capable of doing. So we kind of try to maybe take advantage of some of those features as well. So there may end up being 2 different, file formats, kind of like a native and then a flipper support for the captures ultimately, just not there now, but that'd be planned for the future.
Because for the future also, you have planned to implement both, I mean, 2, sorry, transceiver in an early version of the Wave Sentinel when you first call it Clipper 1. Could you talk a bit more about this implementation?
Yeah, initially there was some interest to do that. There's some other project out there that's I've got something that's similar to that. But the challenge that I ran into with that is more like a physical challenge, with the transceivers being so close to each other, without separating the two. By a little bit of a distance anyway, they would interfere with each other, or could potentially interfere with each other. So I think ultimately what we've decided to do is there's some commented code in the open source that would allow you to do that, and it obviously would need some more work to be able to support both modules. We did the wiring and did the testing, and it does work. But it's not fully supported, and I think going forward, because the transceivers using the ESP32 as its MCU, it has the Wi-Fi and Bluetooth capability built into it. So we would look to do something where we utilize communication between the MCU, the ESP32, and either an 8266 or another ESP32 with a radio unit attached to it, and be able to still use 2 modules, but one being separate, done via a Wi-Fi or a Bluetooth link. That would be, I think,
okay.
You get better results out of it for if you did it that way. So like I said, that we had a design, and there's still some 3D print STL files that I have for that, if somebody wants to continue to move in that direction. So it would certainly be possible, but the main focus is gone back to a single module, and also looking at some of the RF69 modules as well, and perhaps we may even have a unit where we support the RF69 with one code base and the CC1101 with another code base, because there's some advantages to using one module versus the other. There's pros and cons to either one. So in the future, I might potentially support both of those modules ultimately.
And you have mentioned also about leverage some Bluetooth and Wi-Fi on the current ESP32 board, where like the Flipper Zero needs an addition module for the Wi-Fi. So could you talk more about what you have in mind as a project?
Yes. Yeah, so that was one of the things that drove the using the LCD that I'm using now, and as well, we've also looked at another electro LCD that I've looked at maybe integrating, but the framework is already there. You have the SD card. You already have, all the pins that you need on the back. So using that as the framework with the Wi-Fi and Bluetooth built in just made sense, because now you've got your sub-Ghz radio, you've got your Wi-Fi and Bluetooth capabilities all on one board, with the SD card for logging. So it kind of just made sense to put all that together so that you would have the the things that seem to be the
Mhm.
most interesting to
Mhm.
people that were on the flipper would now be available with actually a larger, color screen, and maybe, a little bit easier UI, at least for old people like me, so I can see the bigger, a little bit bigger. But yeah, that was kind of, yeah, that's the idea, to bring in the Bluetooth and the Wi-Fi capability along with it without having to add separate modules or having stuff hang off
Mhm.
at the edge of the device.
Yeah, so that would be kind of a standalone device, more like the HackerF, where it's like more complete, I would say, on some field of like the radio spectrum, because here, yeah, having already like the Bluetooth and the Wi-Fi, and if you said in the future you could like use two devices to actually capture and replay instead of like being forced to have like a limitation due to like the distance of on both transceiving modules. That's really sounds interesting in terms of like activities you could do like this. What kind of like I would say end user you will target from like is it more let's say enthusiast people, pen tester? Because like we could see with Flipper, it's also bring a lot of like newcomers like me in this field.
Yeah, I mean, hopefully it will bring some more people into the field,
Mhm.
and because a lot of those things, especially like when it comes to pen testing,
Mhm.
um, because of devices like the Flipper, the HackRF, we've found that there are gaps in security, especially when it comes to your house, your home, your
Mhm.
business. So it's kind of multiple things. It allows you to take a look at your own equipment. Hopefully people won't use it in a nefarious way to do things that they shouldn't do with it. Allows you to do some testing, so that if
Mhm.
you are using other sub-gigahertz devices, you can test the communication between them. Also, one thing that I think um, it, that I want to have in here, it's we actually have the button for it yet, but I don't have the interface written for it, is to be able to take your existing remotes that you have and combine
Mhm.
them into one unit. So
Oh.
essentially, you would be able to sit there with one device and be able to control your ceiling fans. You'd be able to maybe release the door lock.
Mhm.
Even just as simple as making a backup of your remote, because sometimes those get lost and you can't. Then
Yeah.
you're done for. So it gives you a way to back those things up.
Mhm.
I think it kind of targets. At least I think once the firmware gets evolved a little bit more, we'll target home users that it'll be very simple.
Mhm.
We have a kit available, and I think maybe ultimately we may actually end up having an assembled product available. But it'll give pen testers something that is a little bit more all-in-one, kind of all-inclusive handheld device for doing those sorts of tests. Um, Want to have the source open, so that if there are
Mhm.
certain things that you want to customize or utilize or test within the environment, you sort of already have the framework
Mhm.
there, and you can put those things in that you have that are for a specific need that you might
Mhm.
have. So that's kind of generally the target audience for the device.
Yeah, I really like you have both step one in like the user field, because you also see what is the Flipper Zero, you use the functionality, and so other part as a maker and even more advanced, because yeah, you're actually building stuff that could even be, let's say, yeah, and you're selling it like for now, like still like up in a ramp for like having new functionalities implemented, but that could be manufactured in the end. And that's really interesting to have both of this perspective. And in that way, do you have actually a working prototype here you could show us as a demo right now?
Sure. Yeah. I have the unit that I test and work with now. Let me go ahead and kick on the other cam here. So this is the 3D printed prototype so far. We've got 2 buttons on the side here. One is for the power. The second switch is to enable flash mode, DFU mode, so we can put it into flash mode without having to go back in the back and short pin 0 to ground and all that fun stuff. So kind of functions as a flash and run switch. So then when we're in run mode, we can hit the button and turn the unit on, and we get the display on here. It's all touch screen. There's a primary menu with the main applications. There's room for more buttons here for more applications. So like, for example, we go to the Wi-Fi area. I've got just a basic Wi-Fi scanner here, and it's a tab design, so we can add more apps. So this is an empty page now, just kind of showing you that we can add, we can keep adding more tabs here for separate applications. I can hit my scan Wi-Fi, and it'll go in and scan the networks and show me what Wi-Fi networks are around, as you can see here. See how well you can see that, but anyway, and then you can select one of the SSIDs. You may angle it like that, see it a little bit better. So if you were wanting to, join the Wi-Fi or perform a particular test on that Wi-Fi, you would select it and then go to your testing screen. Some of this still is, obviously needs to be developed right now. That's kind of all we're doing in the Wi-Fi section. We've built in the kind of like a scanner.
Sorry, Troy, could you move a bit? Yeah, here it's
better. Let me shut the light up behind me. I think I got a light behind me that's giving me a little bit of glare. Let me just kill that real quick. Maybe that's a little bit better.
Yeah, that's better. Yeah, because we don't have all the full screen of like the module. Yeah, here is great. Yeah.
Pretty good. So start and stop frequencies. We've got a preset touch drop down on the side that will set the presets in here. A scan button, which is not enabled yet to allow me to scan through the presets. That's still going to be implemented. Excuse me, our RSSI threshold. So the level of strength that we need in order for the signal to be displayed on the screen. So like we can turn it on here, probably usually pick up something close by here. I've got another, there we go. I'm going to hit this little button on this little device here. And so you can kind of see the frequency and the signal level come up. There's also a packet generator that will generate a particular color's not great, so you can see the frequency up top there. Same thing, the preset drop down. And turning this on will generate a test packet on this particular frequency, a set of test packets, and then working with some of the settings for the CC1101, like the modulation, the packet format, the bandwidth for receive. There's some other options that are going to go in here that will directly control the registers that are in the CC1101. So you can, pretty granular control over the interface. This is still a work in project work in process. But yeah, you can adjust everything that's on here right now is functional. So you can adjust your modulation schemes. I don't know if you can see that real well. But
it's getting the focus.
Yeah, it's kind of, let me see if I can. Anyway, it shows there.
Oh, yeah, my picture here. Moving it.
Anyway, it's it's 2FSK, 4FSK, GFSK, MSK, and ASK/OK for your modulation format. So essentially, it just allows you to select the different formats for the CC1101. And then we also have some of the RC switch for like the outlets. We can go in here and set the dip switches and send the on command to turn it on or to turn it off. You can adjust the frequency here.
So now people at your home will say, stop, you should switch off everything.
Actually go and turn everything off. Probably going to be some brute force, apps in here, some options in here. And again, another tab for another, there's different things that we're going to implement within the RC switch library. Hopefully you can see this okay. And then we've got the It's just a typical kind of protocol analyzer. And again, I'm just gonna,
Mhm.
you can see the button here that I'm gonna
Yeah.
push here, and let me turn it on. And so it'll show the,
Great.
the raw data that's it's being detected, the binary, and the received decimal bit length, pulse length protocol, that sort of thing, all in here. Working on a function now so that the replay, so once you
Yeah.
capture it, you can just hit replay and replay this back. This works right now, but there's an issue with something in the modulations. I'm still working on that, so it's not completely functional yet, but that's on its way. And then we've got, it also has RS-485 capabilities, so we're going to be putting some testing tools in here for RS-485. There's a port on the bottom. It has the RS-485 right here. And then we've got the infamous flipper piece here. That plays all the flipper stuff.
Yeah.
So you go in here and essentially, select your folder and then which one of the sub files you want to play, and then we would transmit it, and it will transmit it and show you that it played it across the top here. Then, of course, I told you we had our dedicated Tesla button that does both Europe and United States. So you can hit that, and it will play the Tesla, both of the Tesla patterns, both frequencies rather. And then this is also OTA updatable, so it can be updated over Wi-Fi if you want. It can also be updated by putting the firmware package on the SD card and starting the unit up, and it will automatically update itself and then delete the firmware file. Right now, it's just running in access point mode. I'm going to set up station mode so you can join it to your Wi-Fi and just push it across your own network if you need to. If you want to rotate the screen, you can kind of flip it around, and it'll flip around the other direction. If you want to use it
That's
the other
for me
way.
because I switch the screen in the wrong direction from.
Yeah, that makes it kind of easy. And then we're back around this side. And then I think this is going to be the record to capture, which right now I don't have it set up functional wise. It also has a speaker, so we can do, going to eventually work some voice prompting into this. I think that should make it kind of handy. Right now, it just plays a test file that's on the SD card.
Nice.
And that's kind of where it's at right now. It's like I said, it's got some functionality. There's another tool that we're going to implement in here, the 1101 tool. You may have seen there's a repo on GitHub that will allow you to attach the like a Nano or our smaller Arduino processor right to the CC1101, and then you can send commands to it over serial. And so this is going to mimic the same thing. You'll be able to send the command and then see the response back, and then we'll probably have some pre-canned commands in there as well in the drop down that you can just drop down and run the previous commands that you've ran or some pre-canned ones. So that's the idea anyway, just not there yet, but that's the interfaces we're starting to build for it. So that's where it's at right now, and
Wow,
it's pretty easy. Couple of screws hold it together. You've got your ports on the bottom for, if you can see how well you can see this, but you got your SD card. So you've got your USB-C port, which is for the screen itself, the RS-485, which is also part of the LCD screen, and then the SD card slot. And then down here is a separate USB-C port that just supports the charge module. Ideally, I'd like to have that all integrated, but right now I have a separate module dealing with charging because I don't have a custom PC board created for it yet. And then the case is all just printed. I think I've got another one here I can kind of show you. It's a 3D printed case, the switch embedded in it. Speaker goes up top here on the inside. So yeah, that's basically it. Your CC1101 module goes in here, kind of down at an angle, and then it drops down, and then the two screws hold it in place. The switch snaps in. I made it so it easily snaps in the side. You don't have to use any glue or anything. Just solder it up, and you're good to go. You're ready to use the mode switch on the side. And that's basically that's basically what it looks like right now. That's where we're at with it.
I'm really impressed because it's not only a few functionalities, already a lot with a lot of working one. What kind of battery did you integrate on your prototype at that point?
So this unit, here's the double module one that we were working on when it was still the Clipper, and so internally it's a 3,000 milliamp, so it should give you pretty good runtime in there, and I think I've left it on accidentally in the office at night. Again, just sitting there. I'm not using the transmitter, I'm sure, but I've left it on in the office. Went to bed and woke up, and it's still on in the morning. Again, the more you use the radio, obviously, the more that's going to tax that. But the other thing, that you got to keep in mind with this too is the CC1101 modules. Essentially, when it goes out to the antenna, there's a filter network that is between the chip and the actual antenna, and that is where changing those components are what's different when you buy the 868 megahertz module versus the 433 megahertz versus the 315. So each one of those different frequency sets will have different components on the output of the antenna. So one of the things that we've looked at is using potentially maybe changing the filter design or coming up with a PC board that will have the charge capabilities, where you plug the battery in, the power button, all that will all be integrated into one circuit board with a jack at the end, so that or sockets, a socketed port at the end. So essentially, you can change out the CC1101 module. So if because you can put 315 megahertz on a 433 megahertz module, and it will work, but it won't be anywhere near as efficient, or the range won't be as good as if you use it in the range that it's designated to be on, because those components, the filtering components, are different. The bandpass filters are a little different. So that's one of the things that we kind of want to consider in building another board, is to be able to do that, and potentially maybe even having a way to switch between two different sets of bandpass filters for depending on the frequency that the unit's operating at. So that, I think, is probably what they're doing a little bit in the Flipper Zero, without looking at the schematics in depth. I imagine they're doing something to that degree, or potentially the bandpass filters maybe not there. I don't know. I'd have to look at the schematics, but with this, that's something that we're kind of wanting to take a look at, is how to make the front end of it and the transmit bandpass filter side of it efficient. So that's one of the challenges. Another reason why we're looking at maybe some other modules as well. So we may not stick with the CC1101 ultimately, or we may have a source for CC1101 and maybe another source for the RF69 module potentially.
Because I have seen for the Flipper Zero, some people were designing modules with amplifiers and even using different one, because like it seems, I'm not expert once again, like if you want to use amplifier or something, maybe the WCC 1101 might be limited. So that's why maybe, yeah, could be interesting to explore more modules.
And that may be another thing too. One of the options that you can do with that, obviously, is use an amplifier. So if you're trying to cover something in a 315 megahertz range with a 433 megahertz pass filter on it, obviously some of the RF is still going to get out, but it won't be as effective. However, if you're running that into an amplifier, then that may kind of negate that issue, and obviously your range is going to be extended. I did pick up, I was looking to see if I had it here, but I did pick up an amplifier to do some testing with, to see if that potentially will solve some of the problems.
Because me at my stage, I just try to see a bit the range of my modified module on the Flipper Zero. It was quick and dirty, and the internal one and my fan remote, and basically outdoor without any, I was think anything in my sight. So it was in a park. I was still able to reach 100 meters with both of them. So yeah, in feet, my comparison now is not good, but more than 60 feet. So yeah, I was like, okay, here maybe it's not like a kind of a mind blowing because I'm not indoor with, let's say, wall of concrete and stuff like that. But
Right.
yeah.
Oh, that's I mean pretty good if you're getting 60 feet or so, 60, 80, 100 feet or greater, especially if you're outside of the
Yeah.
band design for it. That's probably going to be fine. That's probably going to be fine. Or for most people, it may not be the most efficient, but will it work? Yeah, it'll probably work.
Yeah, indeed, because like, yeah, it's still small electronics. So yeah, and here do you have already some feedbacks from like the community, because you have a Discord. That's how I get in touch with you, and I've seen like some people already built their own and sending pictures. So were they working on the same aspect as you, or could you describe a bit?
I haven't, other than getting some, helping some folks get the unit flashed, and 'cause initially that can be a little challenging if you haven't worked with the that particular LCD module before. So beyond that, I haven't really gotten a lot of feedback. I have one user over in the UK that does some testing for me, and we have made some changes to the protocol analyzer. And made some tweaks that have seemed to have improved it, especially in the scanner, the CC1101 scanner that we have in there. That seems to be better. We've made some improvements on that. But no, really, still in the very beginnings, and kind of looking for some more contributors, some folks that would be interested in contributing to some of the code. I think most of the folks that I've had interactions with have purchased the components for it and put it together, but haven't really done much as far as any kind of code development. So that would be nice to kind of get that side of the house moving, and getting some people that are interested in that. Hopefully, that would help drive some more features. Again, I'd love to work on it all day long, but my time is so limited, so I've kind of got to find time to do this. And I'm hoping that we kind of brought it far enough that some other people get interested, and we start to see some code contributions, some other things that people like into it. And then there may be some folks that are kind of doing their own thing, and they're keeping their code private to themselves. That is certainly a possibility. But I think at least 6-8 people out there that I know that have built it anyway. But haven't had a lot of feedback beyond that, beyond that part of it.
Yeah, so here in this video, it's our call for developers. So I'm sure like some people will be curious and see more than just this video, browse also in the GitHub. So yeah, Troy, it's up to you to say what you're like, you're looking as a help contribution, because like I also, pay you coffees as a friend, I go in the bar and like, okay, let's talk a bit about what's up. And if because here it's open source, so you don't have like a company selling this product. It's all everything on your own free time. So that's also why I wanted to make this video to promote this work and this devotion for the community in the end, because like you give without like asking for anything back. It's here on GitHub sitting, and you're still like improving it.
Yeah, I mean that's I enjoy. I don't like to hide the knowledge that I have and kind of keep it private if I find something out, especially if it was things like getting those WT32 modules working with LVGL, and get just that in alone can be a little challenging. So getting that together, getting the SPI bus to work with the radio and kind of pulling it all together, even the sound part of it, pulling that all into it, took a lot of banging my head against the wall. But I feel like once you figure it out, it's a good thing to share the knowledge, because I think as a collective, we do better things as a collective when many people contribute. You end up with you have a lot more minds thinking about a lot more things, and a lot more possibilities kind of come to the table. People are able to put their knowledge together as a cohesive thing that I think you get a lot more out of if you do that, rather than try to sit behind the scenes and develop some private firmware and sell it off. I think that's maybe for some people it's great and it works for certain things, but I think for things like this, we get a lot further when we share the knowledge, and we try to empower each other with ideas and knowledge. And so when you get a collective of people putting that together, I think you just end up with something far superior than relying on one or two developers to put things together. That was at least that's my theory anyway. We'll see what happens.
Yeah, I really share it, and I'm, I think, aligned. I mean, I'm not developing or sharing, unfortunately, a lot of things right now, besides like maybe promoting some work and giving idea for people to dig into something. So that's here my contribution so far, and hopefully I could grow and bring some more into the project. And yeah, I have also another question that came into my mind, because here, like, you were talking about the difficulties about using the WT32 module. How did you come to this one? You was like reading all day long space about device, because when I look at first, I was like, this is kind of advertised as let's say IoT device, of course, but the one that maybe some people will use as a remote for home, controlling or home assistance, something like this. So what make you decide this one rather than maybe using another one? Yeah, I don't have an example, but yeah.
Yeah, no, there are some other ones. I have done some projects with next gen modules. I've got a little piece here. See it here, that we use next gen modules with, and that has a certain interface that's actually very useful. It's great. The modules, the LCD modules are a bit more expensive, but they have some great functionality. So I've looked at different modules, and really the one thing that I've looked for and haven't really yet found the perfect combination for it would be the LCD modules. Use the ESP32. I've been developing with ESP32 for a while, so I'm very comfortable with it. And most all my other projects utilize ESP32s. So already being comfortable with that, I wanted something similar to like what you find in the M5 stack platform, where you've got the embedded charger for the LiPo, and not only just the charger, but there's actually a battery management system in there. So aside from a voltage divider, a couple of resistors go into one of the sense pins on your MCU. There's some intelligence to it, so you when it's charging, what the discharge rate is, how much current you're pushing through the battery. So there's some intelligence involved in the battery management. So battery management, SD card being already attached, and then having I2S also for sound together all in one package is really kind of what attracted me and what makes me look at the LCD development components, because the more I can get that's already on the board is less that I have to design in the product. So I don't, there's some products where I don't even have to worry about dealing with the with a separate PC board to handle those things. It's already like, for example, the M5, it's all there, it's all built in. So everything I need is really there, except for the sensors and the components that I'm going to be using. So add those in, code it up, and it's it's kind of like rapid application development. You're getting from, 0 to hero quickly without having to go through a bunch of the, lower level things that you might designing a PC board, sending it, having it done, and then usually you got something you got to fix on there, so you get them designed again. And I've gone through iterations of PC boards, and while when you get to the end, it's nice. It takes a lot of time, and obviously there's an expense that goes along with it as well. So, so that's kind of the thing that I look for when I look at the LCD modules, is what kind of functionality can I get out of it? How many GPIO pins are going to be exposed? With the WT32 having 2 CC1101 modules on there is pretty much eating up all the pins that they have available to you. There's just really nothing else left after that. So there may be some other things when it comes to, doing infrared, or getting rid of the RS485 and doing something else, would involve actually removing components off the board. And if you're trying to, some people aren't going to want to do that, and so that's another thing too, is the easeability of, hey, I can take this thing, I can plug these cables in, here's a wiring diagram, plug it into this device, put it all together in this case, and jam some firmware in it, and I'm ready to start testing. Then I've got a platform that I can work with that already has all the tools that I need in it. So that's really what I look for when I'm, targeting an LCD or an environment for for a prototype. Those are some of the most important functions, I think.
Okay. And maybe I was thinking, in the future, what would be like the next feature that you, if you want to tell us, you plan to implement, but it's not there yet. It's still in your mind as a kind of like you said before, to make something really easy, to have like all the list of switch where you could like program it, all your remote in one device. Is there any feature like this that you make that you want to develop?
Absolutely, yeah. The things that we were discussing as far as being able to take one device and have all of your sub-gigahertz remotes on one device, and have to have all these things laying all over your table, kind of like the universal remote is for the the TV. Same idea, and have that in one compact device that can sit there, and you can pop the garage door, you can unlock the front door, turn on your your lights, those sorts of things that you typically do. You can drive your spouse crazy and keep ringing the doorbell while you're sitting on the couch. Those important things, I think they're attractive. It makes it nice, especially in a home automation scenario. I'd love to see some crossover into maybe even potentially some home automation scenarios where you can open the blinds, the sort of things we're talking about, that could be brought into that. So that's one of the ideas that thought about doing something like that. And then on the Wi-Fi front, so right now kind of exposed the menu and an app to go out and scan the Wi-Fi networks and give you the RSSI, and beyond that, it's not really doing much. So I'd like to take that and run further with that, and bring in some of the pen testing capabilities, so you can go in and select the access points you want to test with, and perform some of the tests that a typical pen testing person might do with their own Wi-Fi network, or obviously a network they're authorized to test on. So yeah, that's the idea, is to bring some of those tools and allow people to that aren't necessarily familiar with using laptops and Linux and aircrack and all that kind of fun stuff. Just to kind of give them some of those basic tool sets without having to really understand all of those components. So that would be probably the next goal. After you kind of get the sub-gigahertz where it's tight and things are working well, then that would be the next I think natural thing to do would be to expose the Bluetooth and Wi-Fi capabilities within the ESP32 and take advantage of those things and kind of write some applications around that to support those features. That would be probably the two most high priority things to do after we get the sub-gigahertz nailed.
That would be awesome. And just hearing maybe I have a picture of using the Wave Sentinel as a kind of gateway from different sub-gigahertz device in home automation, something, or just for testing somehow, because I've seen some people that use switch button on a remote. And I'm like, okay, that's fully working. I mean, why am I to judge it? But here it will bypass one step because, like, if who knows, like the switch bot is still like doing the press on the remote, but the remote battery is dead, and you're stuck here. You could use right away the Wave Sentinel and transmit like the open door of my garage or whatsoever. So
yeah, exactly. If you were to lose a remote or you needed to clone it for whatever reason, you'd be able to do that, and then being able to store it as well, so that you could just pull it up. You can just say, hey, give me my garage remote, boom, and now you've got your garage components right there on the screen. So an interface for that. I've thought about how to kind of how to work the interface, because that's another challenge that you kind of look at when you're putting this together. The interface originally was kind of one design, and then we brought in tabs in order to limit the amount of memory that's used, because a lot of times in LVGL the screens are all loaded all at the same time, so it's all consumed memory, where some of the functionality, especially in the new release of Squareline, allows you to unload screens until you need them again, which pulls it out of memory. Because that's one of the things that ran into with this. We started adding screens, and then we hit a point where I flashed the unit and it wouldn't come back up again, and or it had some really strange, started acting really strange, and come to find out it was because it was running out of memory. So between some code changes to allow some more memory for LVGL and making some changes in the design, we made it so it's a little bit more efficient on the memory side of it, so we can expand and have more apps, more buttons and things in there without having to worry about running out of memory as quickly anyway. Obviously, at some point you're going to hit a limit, but it opened up a lot, being able to deal with the memory in there. So that's one of the gotchas that kind of, as you go through dealing with this and developing this, the things you run into, and then you've got to figure out a way around it, and or switch to another platform, add more memory. Those are the kind of things. That's another reason that I didn't mention when targeting an LCD system for development, is the amount of memory that it has available to it. So there's certain flavors of ESP32 chips that have 2 gigs of PS RAM, 4 gigs of PS RAM. So the WT32, the SC01 Plus, had, I think it's the N16R2 variant, which has essentially 16 megabit of RAM and 2 megabit of, I think it was, PS RAM. So you have more room for those components to live in there. So obviously that is going to dictate how much application room you have for the user interface. So that's something that you're going to run into as well. So that's one of the things as well that would change the targeting for that, or what is going to live inside the application. And another reason why I've looked at maybe doing different code bases for different functionality or radio system. So you might have one functionality with the Wave Sentinel for doing penetration testing, and maybe another one that is strictly designed for home automation, where it syncs in with home automation and has those types of functionality built into it. So, or even the capability of loading some of that stuff off of a SD card, so that you could have a lot of stuff in there, but pulling it up off the SD card. So those are some of the things that we haven't even ventured into yet, but I suspect somewhere along the way that's gonna come up.
Oh, that's really exciting, because at that point, even like the interface, I found it really user friendly with like all the icons, the colors. It's really different from what we used to. Like if I could compare from a Flipper Zero or even HackerRef, it's way different here. Like I feel like the touch screen, even if it's like not as as a smartphone, it's still like fluid, and you could pinpoint on the icon. It's big enough, because the HackerRef almost you need to use a tillet, and on the Flipper, of course, you have the D-pad, but it's not the same feeling.
Right. Yeah, I felt like the touchpad gives you the most flexibility when it comes to the user interface. Just everybody's and like you said, it's definitely not as fast as a smartphone, but it's not the processor's much smaller processor. But I tell you, for the TFT model, the parallel models of the TFT, which is like the Electro model that we're looking at. I've got a couple of those, and those actually work a little faster with transitions and things like that because of the architecture of the TFT. It's 8-bit parallel as opposed to SPI. So there's data can move faster. To the device, to the TFT device. So yeah, that's one thing that's nice about it. It's kind of like I say, as long as you got the memory, you kind of can infinitely add the things you want in there, and create the screens that you need, and hopefully get the functionality out of it. That's the idea anyway. Yeah.
Yeah, that's why we talk about today, like to bring more people to make this happen faster.
Yeah, exactly. Like I said, I wish I had time. I wish I had a lot of time, because I would love, to sit and mess with this more, especially like I said, looking at the passband for the antenna. I've got some pretty good test equipment that we use in the law enforcement arena and in public safety. So it's very competent, good test equipment, and I'd love to be able to get some better designs for like the front end and things like that, have the room for and the time for that. But I just got to work with what we got available. Switching out modules, maybe the way we end up having to go. I don't know, but yeah, I wish I had a lot more time, and about 10 years more coding experience. Because I'm not a coder by heart, and so a lot of what I do is I'm learning from others as well as the community, and that's another reason why this is kind of a nice thing, because everybody gets to learn something from it, and I think as long as you're doing that, it's great. I feel like I'm lost if I don't learn something every day, So that's probably part of my ADHD.
Yeah, I have that too. Yeah, I understand.
But this helps fulfill that. So
yeah, it's a rabbit hole. Like there is so many stuff like to learn about. Like when you mentioned this module first time on the channel, I was like, wow, another one, ESP32. And like when I opened the datasheet, I'm like, oh my god, please Troy, which pin I should like wire, and like in the GitHub it's here. So I was like looking all your designs. So we have already been blessed with like the good documentation to follow your prototypes.
Yeah, hopefully it's not too hard. Like I said, I'd love to have the time to put something together a little bit more comprehensive and better laid out. But I think if you take a look at it, you can kind of figure out what goes where, and most people have not had too much trouble with that. Again, the flashing has usually been an issue. Or with one thing I've also run into with this is different versions of the Espressif development framework from my version or my installation of VS Code with the platform IO extension. Somebody else might have a different version of the Espressif framework installed, and we've run into some issues with compiling where I'm compiling and it works fine. If another person compiles and they get an error about memory or something like that, and typically changing the board type or the framework version, forcing a particular framework version has worked well. But when I am doing the commits, at least for the firmware that I'm doing right now, what I'm trying to do is put it out on a web. On the GitHub, there's a link to the web flash, so you can actually go there and just connect your device and let it flash your unit, and you don't have to, no questions asked.
Yeah,
So
indeed.
hopefully that helps. Hopefully that helps.
That's helping me a lot. That's the way I flashed. First, I had an issue to put in DFU mode, and I
Right.
gave up a long time ago. I thought even I should like bought like the GST dev board cable because they sold one separately, and I was
Right.
like,
Right.
what should I do? Should I flash over like the serial, or should I flash over like the USB that I should be able to put in the view? But I feel a bit dumb, and then I leave it for a long time, and someone or asks a question, and you update like the documentation, and I see like I need to make like two pins put together and at first boot, and then it put in DFU. If you could like just confirm if you see what I was talking
Yeah.
about. Yeah.
Yeah. No. Exactly. Yeah. That's the one thing. See, when I bought the first batch of boards that I used. In fact, I still I've never bought their little serial, unit that comes with it. I never bought that. And so I think a lot of folks did. And I don't think, and again, I don't have that particular unit. I know you can plug it in and put it into boot mode, which is nice. But you can also just take a little screwdriver and short the first two
Yeah,
pins.
voilà.
Usually that works that's usually what I end up doing. And then using the built-in USB-C port, because a lot of people were trying to flash the serial side of it with that little extra board that they send you, and yeah, you don't need that at all. You can just toss that to the side. It might be good to put it into boot mode. But like I said, if you just short the boot 0 pin to ground and they're right next to each other on the debug port there, it makes it real easy. And that's also why we added the switch on the case, right? So it makes it really, even though it's OTA flashable and things like that, inevitably something happens sometimes somewhere along the way. You can always put it in DFU mode and reflash the firmware. So I figured that was kind of the safest way to do it. But yeah, you're right. That's the best way to do it is right through the USB-C that's built into it, and short pin 0, GPIO 0 to ground, and that's on the debug port, and plug the USB-C in so it's powered up, and then you can let the short go. It doesn't matter. You just need to short it when you first power it up. You can release the short after that, no problem. And then you flash the firmware. Another thing I did that we've changed it now, so I doubt anybody would run into it. The one thing that I had done before in the code was I was trying to initialize SPIFs, which is the SPI file system, prior to initializing the user interface. And so what was happening, and it happened to me, is on the very first flash, if the SPIF file system or SPI FFS system is not present, it will create it. And to create that, it takes about 20 seconds. And so what would happen is it would flash, and then you would think the unit didn't work because the display was blank. It was just black. And if you waited for about 20-25 seconds, it would come up, and then everything was fine. After that, it would come up no problem quickly because the file system already exists. So the one thing we did do is move the order into which we do that, so that the UI comes up first, and then it will initialize the SPI file system, so that you don't think that it didn't flash, because that was also things like, I discovered it, I flashed it, and I'm like, oh no, it's something else went wrong, and I just set it on my desk and went to bed. And when I got up the next morning, it was on, sitting there on my desk on. I'm like, what? So yeah, I figured out that that's exactly what was happening. So one of the things you learn along the way, but yeah, that's with the web-based Flash tool. It makes it easier because you don't really have to have the development environment up. If you just want to plug it in and play with it, you can do that right off the bat. But obviously, if you want to contribute and add some code and customize the features, what have you, you'll want to get the platform IO set up as the one of the extensions for VS Code. So install the VS Code, install your platform IO, and then you'll have to add the board in, the ESP32 board in order for the support for it. But after that, it's pretty, it should be pretty straightforward. Pull the GitHub repo down, and that's another thing that I would recommend. As soon as you get your platform IO set up, is install the GitHub plugin, because then you're going to be able to sync that stuff and pull it down, and have it link up with GitHub. So it makes it a lot easier that way. And then there's also some other things that I've figured out about flashing it. So if you do want to use the Espressif Flash tool, I think the latest version was 3.95, I think, or 3.9.5. There's a way to do that as well, but I would have to push out the firmware, the bootloader, and the file system, the partition bins out to the repo in order for somebody to do that. But I don't think anybody really needs to do that, but it's an option if somebody wants to try it that way. That's for a little bit more advanced,
Yeah, I was saying, like, this video will be like tools and knowledge for people that want to play and see maybe if it was not mentioned yet in the Discord or on GitHub.
Right. Yeah, exactly. Yeah. Hopefully that helps. That I know that snagged a lot of people up, but yeah, hopefully that makes it a little easier. And like I said, the web Flash tool makes it real easy. You plug it in.
It's really awesome, because first when I wanted to buy it, and I was like, hey, it's module serial modules that they sell. It's almost $10, and I'm like, the whole LCD module, it was like 30 at that time. So I was like, wow, that's kind of a lot, and I am already beset with like the Flipper Zero that could act like UART to USB. If I want to use the serial, maybe I just need to play a bit with all like the pin on the board. That's maybe not handy, but that's still manageable if I need. So yeah, thanks to your work, the web is the way to do.
Yeah, much easier that way. Yeah, much easier. Yeah. That way you don't have to have any of the without the development environment set up. Especially for somebody that doesn't want to code. They just want to flash the firmware and use it. That makes it a whole lot easier. And I'm glad Espressif they provided that tool, so it was pretty easy to implement into a website. It actually can be implemented right on GitHub as well. I haven't gone that route. I actually have it hosted on another site. But I will eventually have that Flash tool embedded into the GitHub repo, where you'll just be able to go right to the GitHub repo and flash it right out of there. That should make it a lot easier. One of these days, when we get some more time, right? Once we get 36 hours in a day, we'll make it happen.
I really like your way to think. Yeah, definitely. Time is what we all need. Yeah.
Oh my gosh, yeah. That's for sure.
Maybe we miss something I should cover as my question. Maybe you want to add something?
Well, like I said, it'd be really nice to have some more people that, especially are familiar with the CC 1101, get involved, contribute something, and maybe they've got some knowledge they could share. Hop in the the GitHub or rather the Discord server. So it'd be good maybe to have that available. It's available on my YouTube and obviously
Yeah.
on the GitHub site. But if you want to include it, that would be great.
Yes.
And then also if I've also got a kit on Tindy that's available, mainly because it's easy to go out and get the module, the LCD module. The tricky piece is the FFC, the flex connector, and the extender. Those are kind of hard to find, and I have that all available in a kit, and it's available on Tindy as well. So maybe I can give you the link for that, and if somebody wants to just
Sure.
cut the pieces and not have to go hunting for everything, and source everything. And it also, I would also print a case and include a case with it. Eventually, there's some changes I want to make to the case. More on how it comes together. I want less of seam to be shown on there, or either that, or to have the actual rift going around the edge of it, so that there's actually a preset seam around it, just so that it looks better. So probably going to make a couple of more changes to the case. But once the case is final and I know that it's good and solid, then I'll get the cases made, and I won't be 3D printing them anyway. I'll get them made, overseas, and have them shipped, because it's just easier, less mess, less problems, and they turn out really nice. So at some point, like I said, I think, and that'll probably be the point where we get to where we may actually offer an assembled, fully assembled unit ready to go, aside from the kit. So the idea now is to kind of get some experience from some other people, maybe some things that they like or they don't like, implement those changes, and then once we kind of figure out that this is good, then we'll go and do a professionally done case. But they're all done. Right now they're all printed on the Bamboo Labs back there. It does a nice job with the print, so they're pretty clean. So I think I think people will be happy with what's out there right now.
Yeah, definitely. I have printed mine with a different printer, not as good as maybe with the Bamboo, but yeah, I'm pretty happy. I still need to do the wire and get the flex connector. And once this is done from my side, I will be happy to do all sort of testing, and even be a beta tester if I could help, and click on button where I should not be maybe clicking, to see if I could find some bugs. And,
they're in there. There's some in there, but yeah, no, definitely. Yeah, I welcome that. That would be great to have more people, get the input, see what people like. I'm not the best GUI designer, probably, so having some other input is great. I'm happy to make the changes, and the case design, as well as the UI, is a thing that's easy enough for me to do. So yeah, I'd love to see that kind of transgress, and, like I said, come into something that's a nice finished product. That'd be great.
And also, if we want to support you, there is a Ko-fi link I will add in the description as well. So it will be nice, as a friend, I said, hey, a coffee or whatsoever, to say thanks. I think it's nice nowadays. It's a way we work.
Yeah, no, that's great. It helps. The kits too. Essentially, what I do is I take and just reinvest. Don't make very much on the kits, but enough to help try to resupply some more product, and do some things like buy the little little RF modules that we can test with, and try to do some things to make it better. So yeah, anything like that helps. That's great. Yeah. Knowledge is great input too.
Yeah.
Even without the coffee, the knowledge is great. But yeah, appreciate anything, anything to help make it help make it move along. That's a good thing. I always like that.
Okay, great. So thank you, Troy, very much for this talk. It was a nice time spending with you, discussing around like all sorts of project and of course the Wave Sentinel.
Likewise. Yeah. Thanks for having me. This is great.
Yeah. So I will stop now the recording, ensure everything is in Google server. Okay, stop.
Good timing too. My my headset just started going, low battery.
Oh, okay.